Today we have a very special guest, possibly the fastest special guest we've ever had, and probably ever will have. Speed Muller from the Dallas Fort Worth Metroplex. I think most of you know he is the Lone Star Region Treasurer. He's a frequent contributor to the Marker Lamp. He's helped organize the groundbreaking NMRA X conventions, presentations, meets, whatever they're called, virtual gatherings of NMRA members. He's an international superstar in model railroading, a fantastic innovator, an amazing guy, and just an all around perfect guest to have speak with us today on some of the new projects that he's putting together that may be applicable to our own layout here in Austin, Texas. So, Speed, welcome to the AMRS monthly meeting. Now,
Okay, so how do we start this? Many moons ago, I decided that I want to participate in this whole thing called operations, because I've been building this layout for the last, what's it now, 10 years. And when I got to 7.5 years, I realized that this ain't going to get done by no means. So I decided one April, I'm going to sign up for the DFW interchange, which would happen that next November. And you guys might know that's when the Houston people and the Tulsa people come here primarily. And of course, if there's many slots available like there usually is, then we invite people from all over. So from April 1st till November 1st, I slept 4 hours a night. And shortly into April, I realized that I don't have enough cables or enough time to put all the wires into the system. So we're going to have to get rid of the wires, because I have the Mercan bus running halfway. I have a quarter of it running on LCC. And I just realized that cost-wise and cable-wise, this is not going to work for me. So I jumped in onto these little microcontrollers called ESP8266s, and I created something that uses Wi-Fi. And made it to work. There was a few glitches, but it was more track related than electronics related. So, quite proud of myself, but that doesn't make me a worldwide modeler. And we operated probably 10 operating sessions after that. And then I bumped into Joel at the Houston convention, which was beginning of last year, I guess. Yeah, when we still allowed to have questions. And Joel said, hey, how about we do some signals? I heard you have some ESP8266 thing going. And we decided, well, why not? And if you can see here to my left, Joel made this little board, and there's your stop signal in the Penzi world, or who's the other railroad? Joel,
CNO,
help.
BNO,
BNO, CNO, where they use different colors or whatever. So the first problem I had is all the modules that I created here to run my layout, primarily the servos and the sensors, all have my SSID, which is your Wi-Fi network name, call it that, ID, and my Wi-Fi password built into the code and compiled in and uploaded. So if I were to give Joel one of my servo boards, I would have to either know his password and SSID, or I have to give him the code and delete mine first, and then let him type his in, compile all the code, and upload all the code, which is a tedious task, not for Joel, but for anybody else in the world who wants to accomplish the same thing. So after we got Joel's signals to work, we spent the next 9 months making this so you can take this off the shelf, turn it on, use your phone, connect to it, tell it what your SSID is, and hit save and reboot. Okay, so that's how we got here where we are. And we just released weekend before, the binary file for doing the servos, because we believe it's perfect now. Of course not. So here's mqTrains, is what we labeled it. I'm in the Helix, Speed Muller, born and raised in Africa. And all this work was not just my work, it's all done by Joel and David in Australia as well. So on that topic, there's already an NMRA X clinic, mqTT in the model train world. where David McMorran explains how the servo board works with JMRI. And if you look at that link at the bottom that says txnumup.com/NMRIX links, if you can't remember that, just search for txnumup. That's like Texas, even though it stands for transmit, because it's the trans numup. Numup is the desert in the country. And fourth last link says NMRIX links. And when you click on that link, you will get all the clinics that NMRIX has ever given, plus the next 8, but don't tell anybody that because the marketing people will kill me. So there's links where you can click and it goes to the YouTube and you can watch the video. So you go, what is mqTT? Well, raise of hands, who has heard of HTTP? Nobody? A few. FTP, file transfer protocol. How about SMTP, POP3, or IMAP? Or just email? Anybody use email? Okay, so mqTT is not as such a transfer protocol. It uses TCP/IP like anything else, but it works just like the stuff that works behind your email, where you don't really know what it does. So how did this become famous again? Because this was invented long, long time ago when they built the first pipelines through the desert, and they had to get low bandwidth, low data rate to know if there's a leak or a temperature or a problem on the pipeline. There's even a rumor that it went up into space. The first satellite that got launched to broadcast as TV, and they had all the ways to tell us which channels to view on the BBC, but they didn't know how to move the solar panels of the satellite. So mqTT was helping there as well. So the key is low bandwidth, meaning you press a button once every 2 minutes, meaning you throw a turnout also once every 2 minutes. A train comes by once every 5 minutes. So that's only 1 packet or 3 packets per the same 5 minutes, right? So that's really low data rate, which means you don't need Ethernet cable, and you don't need, I'm not going to say this, you might need LCC, but you don't need any cables to transfer video and data at rates that we want today when we get our gigabit Ethernet connection. Okay, so mqTT stands for message queuing, and then the telemetry transport is up for debate. This was invented in 1999 already, before we all had email on our phones. But the only thing that matters to us, it's a lightweight protocol for sending messages, and very, very inexpensive. And that means free, because you don't have to pay for the servers part that you install. You don't have to pay to use the protocol. And you don't have to pay for the code that me and Joel and David's going to give you. Okay, so I think I've covered this one already. It's a simple way to use inexpensive electronic devices to control your layout or your portion of a layout like a club. Very little wiring needed. It does not need DCC. It does not need DC. It will work on any layout, even if it's a dollhouse with the kettle making a noise. So here's the second last slide, because we're going to change this over into you asking questions. This is a typical installation, which was 2 years ago when JMRI just had turnouts installed. So all these little boxes are the devices themselves. So I have here right in the middle my wireless router, and I have here on the right the software that's called, what we use, Mosquito, but it's the mqTT broker. Since version 3.1, they changed the broker to a server. So now you can think of it as just some server, and nothing fancy. It just captures messages and distributes them to whoever's listening. So you don't have to worry about what's happening inside there. You just need to make sure that if you use Windows, that you have the appropriate hole in your firewall if you use the latest version of Mosquito and subsequent other Mosquito brokers, mqTT brokers. And on the left side is your JMRI running on a computer. And today with version 4.23, you have turnouts sensors already built in. So just like you create a LocoNet turnout, LT111 for DCC address, accessory address 111, you can create an MT mosquito turnout, and we'll maybe cover what you put in for the topic after that as a unique system name. Now, 2 years ago, there was no masts in there, but you can create virtual masts. And then I have some code that's already 4 years old that sits somewhere on the our Arduino blog.com. It's a Jython listener, and that code will then, every time a virtual mast goes from clear to stop or to approach, will forward that message onto the MQTT broker. So let's say you click on a turnout in JMRI, it sends a message to the broker. You have a little board out here that I didn't draw because this clinic slide came from the signal part. So a little board over here that's subscribed to that turnout. It gets the message. It says, oh, you got to go throne. So right behind me here, I have the little board with the 4 servos and a little LCD because I want to show you guys how we can show the information that we sent. And here's the brain. And it's just powered by a USB to 3.3 volt converter. So when you click on that turnout, this thing should move here. Careful now, don't short out the computer again. When that turnout moves, you might have a signal that says, oh, you had a stop here. So how about we put you on approach? So JMRI says, publish an approach for a specific signal. And since this guy over here on the left side is subscribed to that mast or signal, he then gets the message approach, and boom, it goes from red to yellow. Now, a train might come through on the block, and then there's another little device that sees, oh, there's a train there. So it published to the broker that a train showed up. And JMRI is subscribed to that sensor. So JMRI says, hey, a train showed up. That means that signal mass has to go to red, or another signal mass has to go to red. So it publishes a message there, and the other signal mass picks up the red, and it displays the red. So that's how simple this is with electronics that cost you sub $100. And let's talk about the price quickly. That thing that was just in my hand is a $2 USB to 3.3 volt converter with a $1.50 Arduino-like ESP01 on top of it, with a $2.50 16-channel servo driver and $2.30 for every servo. So multiply that by 16, you get $32. But if you multiply tortoise machines by 16, you get well over hundreds of dollars. So for less than $50, I can control 16 servos. Or if it's just one servo, it's less than $10. Okay? The signal board sits over here. This is the kind that Joe likes. It's called the, I don't know if you guys can see this. It's a Wemos. What do you call it, Joel? D1?
Wemos D1 Mini.
The Wemos D1 Mini, and it's also less than $2.50. Now, it has a few more pins, so you could enable a few things on that in later code. And what we do here is we have one wire out of this device go to these 7 pixels that's sitting on this board. And there's an Arduino clinic on, or article in the Marker Lamp way back then about one-wire signals. So we send data in with one wire. It goes through all 7 these pixels, and the one wire continues. It goes through that 1 pixel. The one wire continues. It goes to those 2 pixels and on to the last one. And any one of these pixels can go one of 16 million colors. Now, that's a lot for a railroad because you basically only need yellow, red, green, luminous white. I saw a blinking blue one. Someone sent a photo to me the other day. And dark. That's all you need, right? But if you do want to reset the board and see that everything goes fine, you might want to see a purple flash, right? So we can use purple as well. Just kidding. You specify the red, green, blue values, and you can have any color in here you like. So build a mood lamp for your Ninja Turtle gadget downstairs, and you use pink and purple. So not only trains, but, why not? So that's what the signal stuff looks like. Okay, I quickly want to show you guys how we configure these things when we turn them on the first time. How would I do that? So when you turn one of these nodes on and they cannot connect to your Wi-Fi, or they can connect to your Wi-Fi, but they cannot connect to this mqTT broker, it will turn on its own what we call access point, which means you can go to your phone, click on Wi-Fi, and there should be something listed here called mqT or mqTrains -001. So you connect to that. And here's the trouble. I don't know how to get one of these into. Give me 1 second. Okay, so when I go over here to mqT, you don't have to remember this. Let's just go to the home screen. So what I'm going to do is I'm going to change my SSID to something else, save and reboot. And that screen should disappear. Where was the yes, no? Save and reboot. Should be a pop-up saying, are you sure? Okay, let's do it from my phone. Here we go. On my list of Wi-Fi devices, I have something that's called mqTrains -0022. And I already made the serial number 22 because I wanted to show you the servo's move. So you would have a 0001 in the beginning. So now we have to click it. Where'd you go? There we are. Password is mqTrains. This is all documented in the documentation, which I'll show you in a second where that is. So now we connect it, and you don't have internet, so don't go surf the web now, but go over to your browser, and then we type in, very easy, 2.2.2.1, and go. And don't do this from your home computer because you might end up on someone's Coca-Cola website. So it shows up with that same start page. I click on the quick start button at the top. And it loads the same page that we were on right now. I then go over, change the number with a D to a number with a B. And you would then also change the serial number away from 001 to 002, 3, 4, 5 or something. If you guys are in a club, maybe you give people a member number and they start with 1501, so that when you all get together, you have unique devices underneath your layout. You would then type in the layout topic that you want to use as it is in JMRI, and then your Wi-Fi key as well, and you say and reboot, save and reboot. And there's the OK button that we were earlier waiting for. Say OK, and because my router knows about this thing's MAC address, it will reassign the same IP address, and you will lose the access point, and now you can put your phone down. And on this little LCD, which is another $2 gadget, it will show you the IP address that it's connected to. I'm not sure where it's going to focus. These cameras are not very smart. But at the very bottom, it says 10.10.10.172, which now when I go over to on my computer that's on the same network, 10.10.172, I get the original screen back. Okay, so because we did most of the stuff in the quick start, we'll skip all the way to the servo module setup, which tells you that you have one servo attached, and this little blue board by default has an I2C address offset of 0. That makes the I2C address 40, and the update time is 30 milliseconds. So when your servo moves from left to right, it takes 30 milliseconds between each little step. So if you want it to move faster, then you make that number smaller. And if you want it to move slower, like a semaphore, you want really going up slow, then you make that number bigger. But that will be for the whole board. So all your semaphores will then do the same thing. And your servos for turnouts would also go slower. So you might want to spend another $10 and split the two if you need something to go faster than something else. So back to the main menu, we go to Servo Detail. This shows you the servo number 01. So that's the first servo here on the board, plugged into hole number 0. But we call everything in human numbers. So the first one is 1. The last one is 16. And this is where you tell the servo that I want you in the closed position to go to position 291. And these are positions from the left is at about, I think, 100, and to the far right is 500. So when you change this and you say set, let's just figure out where's 1 so we can show you that he's moving. So I'm going to give him a big move, like 400, and I say set. And how are you going to see this? I'm going to make this guy 141 and click set. I don't know, does it show? Maybe in the dark. Okay,
Yep,
it's pointing
there you
up
go.
there.
Yep.
So when I click 400, you'll see it move to the other side. Now in N scale, I only need to move a millimeter. And all my servos driving turnouts have a little Z bend in the piano wire, so it takes up that slack. Because this little micro G servo will push the throw bar straight underneath an N scale turnout out of the way, and it will never move the points again, except for the rubbing when it comes back. So you got to be careful that you do not put these huge G forces onto these tiny little 160 times smaller devices. So always put some place where you can get the tension to be eaten by something else in your turnout. Torus machines don't have that problem because it's always bending the wire. So you take up the slack in the bend. Where in a servo, in my case, I install them in the front of the fascia right here, so I'm pushing straight into the throw bar, and therefore I have to put a Z or a twist in the piano wire. So now you go to the next servo, you do the same for them, and you adjust all your servos so that throw and closed is in the positions where you want them. There's you can disable them. As the dispatcher, you could lock them. You can put them into pairs or in groups of 3, what we call links with a Q for mqTT, so that you can say when you do this crossover, you can move the one servo to close and the other servo to thrown, and then your train will cross over. Why don't we just do it like you do with Torus machines, where you just flip the double pull, double throw switch? Because each servo has to go to its own positions. We can't say move both servos to 300, because the one might have to go to 200 or 305. So that's how we link them together here. And then on the live page, sorry, I skipped this. Oops. If you click on the servo live view, you'll notice that all the others are set to middle, because this is the first appearance of this board 0022 on my layout here. So it doesn't know where the servo needs to go. And when you turn the board on, all the servos move to the center position between the throw and closed, so that your points just simply go loose. And it doesn't force it to some number that you didn't tell it to go to. So every time on power up, you'll hear all your servos go zip for the whole board. So they all jump to the middle. And as soon as they connect to the mqTT broker, the broker will say, hey, number 1, you got to go to close. And then it moves to the close position. So it actually moves to where you left it. And that's one benefit of using an external place to keep your turnout states, because we all know that in JMRI, when you start it up, there's the unknown position, and you have to set a route to move all the points. But you don't know if someone left an engine on the wrong spot, and now you're throwing a turnout under, throwing a switch under wheels. So in this case here, that mqTT broker will remember this through power cycles. And when you come back next time, it's going to go to the middle and then back to close. Now, if I click here on closed, you'll notice that the turnout is moving over to the other side. So click it back here, and there it moves back the other way. And the same for the others. I think I have every fourth one in my hand. That one moved. But it's only a small movement because it hasn't been set up yet. So there's the second one, or number 9. And it's moving so little that you can barely see it. So this is how you can test this. Now, this is not a way to throw your turnouts. We don't want you to use this. But when you set something up, you don't want to open up JMRI and deal with all the number typing in there to just move your servers and figure out where they need to go. But in case you have an emergency and JMRI doesn't want to launch, you come to this web page and you can control your error. Okay, the next slide is where you guys need to ask some questions. So this is easy in a home layout because my Wi-Fi doesn't change here, right? It's always going to be TX-NumUp. I might change the password from time to time because I get so many people coming through that you never know when you get a hacker. And then he parks in the neighbor's parking lot and he hacks into my layout. Well, good news, it's not connected to my house, so you can't get to my printer. Otherwise, you would run through all my paper. In a club situation, you're going to have some wireless router that you bring with you, or the convention is going to give you access to their router, and you have to get these little devices to connect to that. Keep in mind that when your little module cannot connect to the last one it was told to go to, it opens up the access point, and you can get your phone to connect to it and configure it. Okay, so that's how you would set it up. Typically, if me and Joel gets together at a place where we want to run our modules together, then we put them on the same Wi-Fi and the same mqTT broker and use JMRI to control both of them. Okay, so a little bit about JMRI. Some of you might know, some of you might not. JMRI acts a little bit more like Excel than it does like Word. Have you ever noticed that when you open up another Word document, it opens up another application? And if you open up a third Word document, it opens up another application. And when you click print in the first one, you can still edit in the next one. But when you open up Excel and you open up another Excel file, it's the same application. While you're printing from the first Excel file, you cannot edit the other Excel file. Yes, you can, but you got to make sure you open up Excel in a special way that it's a new instance. JMRI itself only has one list of system names. So if you open up one file in JMRI, it fills up the system names and it shows the panels that you decided to show. If you open up another file, it's not a new file. It's just importing all that data and you get more panels, but it adds to the system names from what you just opened up. So if you click save now, it all goes back into one file. And I've seen many people make this mistake where they open up panel 1, open up panel 2, and then they make a change to panel 1, and they save it to 1, and they open up panel, or it's panel 2 is already open, they make a change here, and they save it to panel 2. What have you just done? You've just saved the new panel 1 and the old panel 2 into one panel 1 file, and you've changed panel 2, and you saved both into the second file. So now next time you open the first file, it's going to have everything minus the changes in 2. If you open up the second one, it's going to give you an error. It's going to say, I already have the system name because it wasn't panel 1. Turnout 15 was last time you saved into both. So you can't really edit 2 files at the same time, but you can bring files in. Let's say you have my modules file and you have Joel's modules file. You can open them both up, and if we have nothing conflicting, it will load. And now you save it as show 1 or show 2015, show 2023, better word. And keep in mind that you cannot edit Joel's while JMRI is running with something else as well. So you got to close JMRI completely and only open Joel's, and then you can edit his. So that's something you got to be aware of if you choose to do JMRI to control all these things wirelessly connected. The part that we didn't talk about is this is just the hardware in an inexpensive way to control it. This is not the part where we say that signal has to be clear or that mask has to be clear. Signal has to be green. So all that logic about when a train shows up and the turnout is straight or closed or normal, all those language things you have to come up with. Now, the good thing is that JMRI allows you to do a whole bunch of these things. And if you want something simpler, then you just get a book, you write some Python code, and you control the listening and publishing to the MQTT broker, and you're well on your way. There are things called Node Red, where you can make little blocks and drag lines between them, which would be another easy way to control your signals, turnouts, and sensors and push buttons. And so you could control it that way. But you as the show manager is going to need to know who's going to show up, unless you have an easy way at the beginning of the show saying, hey, it's Joel's, then Speed's, then Peter's, then Steve's, and I want this block to impact that signal and this block to impact that signal over there. So this is how they hook together.
And that's what I was going to ask Speed. If we've got different configurations, we're going to set up one way one weekend and another way another weekend. How complicated is it to switch those things around and to change the logic? I mean, is that something that needs to be done ahead of time, or can that be done on the fly when people show up?
I think if you're fast enough, you can do it on the day of, because what if Joel doesn't show up? Then
Right.
you have it all configured and he's not there. But it's also not a lot of information that you need to know from the next module. Like in the case of JMRI, where the masked logic looks at the next mask and the stuff in between. So you just have to, in your logic for those parts that in between modules, just have to say, hey, this mask is now looking at Joel's, and the one on Joel's is looking at the one on yours, and you just have to make those selections. And I may suggest that you create virtual signals to that you can just switch over. So instead of using the virtual signal that doesn't exist yet, when that module shows up, I know it's Steve's, so let's point virtual signal 17 to Steve's signal number 1. Keep in mind, all these things have to have unique names, and that's why I suggested that maybe the members get the order in which they joined, or some birthday in front of it, some 2-digit hexadecimal number. So you have from 00 to FF. And that way you can have unique user or system names to control the whole thing in one file.
Yeah.
Wait. I mean, I'm not moving anywhere. So my sensor boards are even numbers. I have 0002, 4, 6, 8. And my servo numbers are the uneven number. So it's 1, 3, 5. And then there's a part where I think I might add some more. So I skip 7 and I go to 9, 11. And then all my signal board starts with a 1. So it's, again, uneven numbers, 1001, 1003, and so forth. So it leaves you a little bit of a room to grow, and there's some logic to it. Just note that in the world of computer science and modern day electronics, people don't think it's a good idea to point certain things out. That thing should not have a real hardware address. That thing should just be a random 64-bit number. Yeah, that makes him anonymous. That makes him unique. That means you don't know who he voted for. But that means that when something goes wrong, you can't find him. And unfortunately, when something goes wrong on a model railroad, you have to find it, right? Where when you do an election, you just wait till 4 years later. Then that's when you fix it. You don't fix it now, right? So just kidding. Any more questions?
Yeah, Speed, this is Mike. Using Java. Well, first of all, I've a long time ago when I had a bunch of Windows 98 computers around and old computers, they said you could put Java on these old computers and it'll work fine. I think I finally got it working on one. And then Java comes up with a new upgrade every month. And it's really laborious to install that on your computer. How do you stay current with Java, or do you have to stay current? Can you just install one and not worry about it for the next 3 years? Or
okay, so I'm a
Yeah.
firm believer in when I bought this phone, it was working. So I believe that 3 years later, it should still be working just as well as it did way back when. Now, security is one thing, hackers is another thing. You got to deal with them in some way or fashion. So at some point, T-Mobile's going to say, you're not connecting to us unless you upgrade, right? But it's not because I
Yeah.
want to upgrade. Okay, so the only reason why you would install Java is because JMRI requires Java, Java Model Railroad Interface. So if you do not upgrade your JMRI, then you do not need to upgrade your Java. But here's the trouble you're going to run into is you're going to save your module in Java version, JMRI version 1. And Riley just joined the club and he installs JMRI version 3. So he saves his file in version 3. And now how do the
Okay.
two get together so that you both use version 4 next year when Peter comes into the club? So you're unfortunately stuck a little bit with the, you got to go with what the newest guy has. Unless you tell the newest guy, hey, install Java 0.1 and install JMRI version 1 so we all use the same version. Okay, so you do have the JMRI issue, but if you use JavaScript like I do, like I only turned JMRI on the other day when I got this TCS throttle, which is a Wi-Fi throttle. It talks to the we throttle server, and I was like, oh crap! Now I need to install JMRI. Now I've been using JMRI on my other computers because we do test this mqTT stuff with JMRI. But my layout simply runs off a web page, and I'm not sure if you guys can see this here. You see a map at the top?
Yeah.
Okay, so now when you scroll down here and you are operating in the town of Swakopmund, on the little panel, the tablet, in the town of Swakopmund, this is what the operator sees. And when he touches this thing here, it sends a message or publishes a message to the broker. The servo board underneath is subscribed to the broker, so the servo board just changed the turnout to go from the team track instead to the field track. Okay? So it looks like JMRI, but that's only because I copied the icons and added the nice little orange circles because that's where your finger needs to go, right? So you notice the blue line, and you notice that there's turnouts here that doesn't touch the blue line or doesn't touch something that resembles a siding. So when we go back to this part here, and what the dispatcher sees looks a little bit more like this. So when you scroll over here to the little town of Swakopmund here at the top, you see the label. Here's that same panel for the dispatcher. And the dispatcher can only control the turnouts on the main line and whatever is touching the siding. Okay, and the label says short siding, so don't park a big train in here when you're the dispatcher. Right, so he has his way of controlling it, and yet again, it's just JavaScript. The interesting thing here is that 75% of the time, our dispatcher sits on a little island called Orkney in the United Kingdom, northern part of Scotland. They are so afraid of seceding from the UK because the rule says that when Scotland secedes, splits from the UK, Orkney goes back to Norway. And I don't think they want that. Or maybe some of them do want that. So by taking the mqTT broker in my house here and the some public mqTT broker that's out there in the Wild West, cloud, Amazon something, by bridging the two, when Gordy touched that turnout, my mqTT broker gets the message and the little servo board gets the message and that turnout changes over. So imagine going to a show, but you're sitting at home. You know, you just like all the N-track clubs, you just need young people to deliver the modules. You don't need to go anymore. I mean, so now you can run trains from far, far away. So if I go over to the west side, why is that part not working? Okay, you see that little red icon in the top left, the red line? When I tip this engine over, it goes white. I don't know if it's hard to see.
Yeah, we can see it.
So engine is gone, engine showed back up. So that's how we do sensors to tell us where things are. Now, the sensor itself is a little bit more expensive because a BD20, which is the easiest to interface here, with 3 loops for N scale, is about, I think, $11 or $12. I built my own, so they cost about $9. And they go into this other little board that has, again, $1.50 and $1.50 chip, and you can have up to 96 I/O pins, and you can tell any pin to be an input and any pin to be an output. The next thing I'm working on is a little capacitive touch sensor, so you can literally touch the switch stand on your turnout, and the sensor will say, "Hey, someone touched me," and JMRI will say, "Let's move it over then." So capacitively touch. We do that every day when we touch this. So for a club layout, you would then either need a dispatcher or some automatic signaling, watching the turnouts and the blocks to decide what the signal is going to show you. Or you have a real dispatcher that sits there and he makes you fill in a track warrant. And you have a real switch list and you go deliver cars. What's wrong with that? So someone did not leave the main line in the right state here. Might have to fire that dispatcher. And that gives you the whole layout all the way from Walvis Bay down south to South Africa.
So Speed, let me make sure, excuse me, let me make sure I understood. So in terms of like wiring, from the physical signal, the LED pixel we were talking about before, you've got a wire or wires going to a little board.
Mm-hmm.
The little board is getting accessory power or something like that from somewhere.
Yeah, so the tiny little board has to get 3.3 volts.
Okay.
That little guy.
All right.
And this guy here takes USB and takes the 5 volts and give it to it. The 3.3.
Okay. So then, is that just connected to power and then it's getting wireless signals, or is it connected to DCC wiring and getting the instructions over DCC?
So,
or is it either one you want?
So there's no instructions over DCC.
Okay.
Now, I use these USB extension cables that has the female on the one side and the male on the other side. And it goes into a phone charger or a 5-volt power supply. So that clicks in there. And on the other side, I plug this in here. And that powers it up. Okay. Now on my layout, instead of having this USB mess, I don't want to say mess, but I cut this end off and I take the red and black wire and I wire it into my 5-volt bus that goes a quarter of the way, because I have a humongous 160 watt 5-volt power supply here.
Okay.
So instead of USB power, it's just 5 volts coming in on the red and black wire. The data wires are cut, so there's 2 pins wasted here where there's data every time you make a change to the to any system or configure it, you can have a serial port, and this is all Joel's doing. He wants to interact with these things serially. So there's serial commands to throw a turnout, and there's serial commands to move where they need to go to, and there's serial commands to set the Wi-Fi SSID in case he needs it. But if you plug it all in to serial, then you just need 12 computers with 12 USB to serial converters, and then you can control everything, right?
Right.
So that's the power situation. All the data comes through the Wi-Fi if you're not using the serial.
Okay.
And JMRI, you guys know that there's a connection for Digitrax. There's a connection for NCE. You can create a second connection for NCE if you have 2 command station. There's a connection for the MER CAN bus. There's a connection for LCC, even though they still call it Open LCB. And in this case, there will be a connection for mqTT. And in the connection settings, you don't pick serial COM5 or devs/TTY USB. You put the IP address in, or I think the server domain name can go in there as well. And then you specify more things under that to control the turnout sensors, masts, and lights through JMRI.
Okay.
So that's the power situation. If you have DCC power, you need to take that plus minus 16 volts and put it through a little rectifier and bring it down to 3.3 volts, and then you can stuff it straight into this.
So that would actually probably be easier than having a separate power bus run all the way around the layout.
Yes, it is, until the train shorts the power out.
Well, we have a 12-volt accessory bus that goes around the entire layout.
There you go.
So we can use that to put some distributed 12-volt to 5-volt or 12-volt to 3.3-volt converters in
Correct.
to drive whatever these ESP boards are that we're using.
Or we can just change the 12 volt to a 3 volt, right?
I would suggest that you go from something like 5 to 3 locally, because as soon as you start dropping the voltage, the current has to go up to deliver the same power. And now you get half a volt drop, and 2.7 is not enough.
Right. And we have some circuits that I usually use a 12-volt bus for my accessories, even though most of my stuff runs on 1.5 or 3-volt.
Mhm.
It's, yeah, I agree with Speed. It's better to deliver it on a 12-volt bus. And then every once in a while, you get a circuit that requires it. And
Correct.
to, have that extra, some
And-
advanced.
And it wasn't my idea. All of you can just walk out to those big power poles and stand there long enough until someone shows up to chase you away, and you ask them, why is that 120,000 volts? And you'll get to the same, they'll tell you the same story,
Right.
or just chase you away.
Or arrest you.
Yeah. But for distribution, higher voltages are better. Now, I have a 5-volt bus that runs, and that's because it goes 5 to 3 on the little, there's a little voltage regulator here. It's actually such a small chip that it's hard to show to people. And it exists on any Arduino, any little, the Pi Pico board has this tiny little 3-pin part or 4-pin part that does that.
As you also said, it only does a quarter of the layout. So you're going to put 4 of those in?
I already have 4.
Mhm.
My layout is evenly split between top and bottom, and then it's basically the helix is kind of in the middle, and then so there's 2 power supplies here doing that way, and then there's 2 on the other end feeding back the ends.
You were talking about shows before. Is there any concern about interference when you have too many layouts operating in the same space at the same time, even though they might be on different Wi-Fi networks?
You just have to make sure that they don't use mqTrains.
Okay.
Industrial sabotage. So I have a really expensive access point here because very early on I ran into the problem where I would lose devices off the network, and everybody would tell you when you buy a WRT54G, you guys remember those Linksys routers with the
blue
black
ones.
antennas, the blue ones, yes.
Yep.
And you could also upgrade them with some Linux software, and it was just cool until they reduced the memory chip size, and people stopped doing that. And then an outcry came, and they made a bigger device so that you could do it again. So I had one of those, and when I got to about 25 devices, I would lose one here and there. So I would simply go reboot the thing, and then it would work again for another 4 hours. Now, the good thing is that an operating session is only 3 hours, but the problem is a show is 8 hours or 12 hours or 3 days if you never change the power, cycle the power, right? So in the last 2 weeks, I've been testing how many nodes can I put on a N router and on a G router, because the one here in the layout room is a AC. It's a $200 access point, which I don't suggest everybody go and buy, but at some point you got to join the 5G club and also move on to the higher speed capable Wi-Fi things. So I found that, or I've been running more than 1 million messages through a WRT54G blue router into 16 nodes in my office. and that's why I had to transport things over here this morning, because I had to go scavenge it out of there. On the DIR, I think 155N router, same thing. I let it run for 3 days and never saw a packet missed. So I said, well, that's the end of this test. The trouble is not so much how many devices you can have on it. The trouble is how many open connections can you have simultaneously to the Raspberry Pi that is running the MQTT broker, or to the Windows 10 computer. And there was my problem. Any trouble I had was always the Windows 10 thing saying, oh, I got an update now. And for some reason, it shuts down the other ports on the thing, right? So you got to reboot the whole computer, and then everything is back to normal again. The new
Steve,
yep.
Did you say 60 or 16s? 1.6 or 6.0?
1.6. 1.6.
Okay, thanks.
Yeah. But here in the layout room, I have more than 35 devices, plus a few here for demos and things. So probably 40 nodes. 40 nodes, and there's also 18 tablets that's also connected to the Wi-Fi that's pulling data off the web server as well. So it's way over 50 devices just in this room.
And that's with the commercial router.
That's with the Ubiquiti. It's a white circle with a blue light in the middle.
Yep, that's what I have in my house.
Yeah, Ubiquiti something. Sorry, AC Pro, I guess. That's actually just the access point. You still need a router with it, little tiny box. And cool toys, because you can now track and limit bandwidth between devices. You can steer certain devices to use less bandwidth, but not a problem here, because literally, I think we have less than 1,000 events during an operating session here. It's remarkable how very little we do throw those double pull, double throw switches on a layout. It's not a million pushes a year. I mean, if I ran,
when you were
go ahead.
when you were demonstrating that servo, there was a wire going into the servo.
Okay. So what's the cat hair doing here? So here's the 4 servos. I'll hang it in front of my shirt. And I have on the other end the LCD. And then there's a black wire that comes in here to power the servos.
The host seems to have picked me. Are you guys seeing Speed or me?
We're
You,
seeing
Dave.
you.
I got
I'm
muted.
seeing David.
Yeah, there you go.
Okay, so 4 servos, even though you can plug in 16, but in order to turn 16 servos on, you're not going to be able to use this electricity here, right? So I'm sending 5 volts straight into the blue board to power this up. Now, where it's installed on my layout, the 5-volt wire here comes from this pin over here, which is the same black cable that comes in here, brings you out to a V out pin. So instead of running this gray cable, I cut the cable off and I solder the red wire in here. So now this is my power on my layout. It's just 2 cables here because we do use the serial cable in the testing to talk to the device and give it commands.
So in our case, if we had a bunch of servos on one module, we would just use a 5-volt step down instead of a 3-volt step down for that particular card, and just use that.
Yes, but you would
Yeah.
need to make sure that there's enough current here,
Right.
because servos do not use a lot of current when it's moving, but when you start pushing on it, or when you turn them on and they have to go from this position to that position in a snap, there's some current being pulled there. And everybody who gets into servos with Arduinos, by the time you plug the 3rd servo in, you'll start realizing that why is the servos keep rebooting my Arduino? Well, because it's pulling too much current and the Arduino resets and it tells the servo to go back to some spot and move again. So then you realize, oh, disconnect the 5 volts from the servos and get the 5 volts from a 5-volt power supply. Because the control signal going into the servo now is only 3.3 volts. And it's just a pulse. It's not a it's not a voltage level decision. The reason we haven't used servos in 1980 was because a 1 millisecond pulse will make a servo go to the far left. A 2.5 millisecond pulse will make it go to the far right. So can you imagine standing at that turnout with your thumb on the double pull, double throw, and you go, ooh, oh, that was 1 millisecond. So then the turnout moves over. And then you want to move it over to the other side. You go, oh, that was 3. Crap, do it again. So people stand there, click, 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 click. No. With Arduinos and things making these electronics super inexpensive, so you don't have to buy your drone electronics or your aircraft controller, which was expensive, and I believe it still is. I mean, you can go to an aircraft hobby store and buy the same little servo for $18, you know, but it's only $2.30 off Hobby King. So even though $18 is still cheaper than the $23 for the tortoise machine, right? I'm not discounting tortoise machines. I just have 220 servos installed here. I could not have done that with tortoise machines. But my biggest excuse is not the price. It's the fact that N-Scale needs less space and tortoise machine is just way too big. And I'll stick to that story.
Oh, you sold me on the price. It's one treasurer to another.
It's just amazing with what we can do. I mean, these pixels is less than $1. So a signal for $1 and it's on a coffee stirrer. You cannot even see what the mass look like. And I made some HO scale signals for a guy here in town, and we literally cut the head part off and we 3D printed our own head, and that pixel just goes into that square hole in the back. And there's power and ground going up and data up and data down. And if you have a 3/3 mast, typical world, that's 7 wires, 1 for each LED and a common. In the 1-wire pixel world, it's data up, data down, power and ground. So,
hey, so I wanted to ask about the addressable pixels since you brought that back up. So, you know, I build PCs. I've got addressable RGB strips and things like that. So I'm kind of familiar. So does that mean that those are they addressable RGB? Do they each have little chips? Each light has a chip with an address on it?
The chip is inside the
light bulb. Yeah.
And it doesn't have an address. It just has a shift register. So 255 is FF, and 255 is FF, and 255 is FF, and that's red, green, blue.
Mm-hmm.
That is 8 bits times 3, it's 24 bits. So if I shove 24 bits into the first pixel, and I give it more time than the timeout, that pixel is going to load the values into the registers and show the color that I sent it. Okay. If I send 24 more bits before the timeout, that guy sends out the first 24 bits. So it shifts up to the next pixel.
Gotcha.
And to the next pixel. And we've shown that you can do easily 200 signal mass or 200 pixels with 1 pin in these electronics because your signals don't change that fast. So it's not like we have to do a glowing show here, right? It goes from clear to approach to stop and then maybe to dark. It's not fading from green to purple to red to yellow. So
now it does seem like we're going to lose a little bit of the economy of scale here in that we can't run a wire from one module to the next module to the next module if we're switching modules around, right?
I don't want you to. I don't want you.
But I mean, I'm just saying we can't string the signals.
No.
You know,
no.
Right? But that's still, I mean, it's still not expensive. But
yeah, it's $1.50 plus $2 to power it.
Right.
Right. So for
well, what I mean is if we've got 16 modules in a row that each have one turnout, right? It's not going to be practical for us to use one board that runs 16
No, no,
yeah,
and these servos have
servos, yeah. But
the
we're still
servos
gonna,
have short
it's still
wires.
cheap enough to do one on each module. I'm just saying.
I would
Won't be
highly
quite the
recommend
same.
that.
Yeah.
I would highly recommend that you do so. So mine is at most. Uh, None of my turnouts is connected to another town's board.
Mhm.
Every little town has its own 1, 2, or 3 boards. In Balfours Bay in the harbor, there's 4 boards underneath. And above it is a little place called Hartsier. There's no cables running up behind it. It has its own board there for the 2 turnouts in town. For the simple debugging effect, unplug the thing and the town is dead.
Mhm.
Right? If you need to move it, you move it.
There's another advantage of having a single processor on each board, each module is that gives us, if we only have one turnout, we still have 15 other servos we can put on that module for any sort of animation we want to do.
Correct. Plus, if you switch 2 modules, then where are you going to connect that one turnout to? Because the next module might not have a spare servo port.
Right.
Right. So I would self-contain them, and so that everybody has their own, so they can go home and run their train at home with their own JMRI or JavaScript or Node-RED, and test it and play with it and show it off. And otherwise, I take my module home and you got the electronics, right? How's that gonna?
One exception would be when you have permanently joined modules like the ones we built for Taylor. The curves are such that you couldn't use any other module with it. Those 3 are transported as 3 separate pieces because of the size, but they would never be used in any other configuration.
Yeah. So logically, it's one module.
Yeah, that's right. So we'd put the guts in the center one, and it's 2 little wings that they don't even have their own legs. They have to be bolted onto the.
Okay.
And so we would just do the electronics on the center one and have some interconnecting wires between them.
So does anybody else have any other questions for Speed while we have them?
Yeah, this is John. I may have missed this at the start. I'm not sure, but it's my understanding that Adobe is no longer supporting
anything to my
knowledge.
Unless you pay a monthly fee.
Well, I don't even know. I think they've totally abandoned Java. So, where does that leave in the future?
Adobe doesn't do Java. Oracle owns Java.
Oracle.
Thinking about Flash, John.
Yeah,
Flash is Adobe, and that's no longer supported, but I don't think Flash is involved here.
Java just changed its usage policy for businesses. They want businesses to get a subscription. So you'll notice there's an extra box to check saying, is this home free personal use, or are you going to pay us?
So does this mean that any updates will no longer come from Adobe, but will come from Oracle?
It's so
right.
So Java was never an Adobe thing. Flash is an Adobe thing. Java was done by Sun,
yeah.
Sun, and then they sold it to Oracle. There were some lawsuits and a fight broke out, and now Oracle has all of it.
Any other questions?
Okay. Yes, Steve, I have one question. How hard is this going to be for Grandpa to install on his layout?
If Grandpa doesn't have one of these phones, then it's going to be a little harder. But we have a support team that covers both sides of Texas. So you take Austin to El Paso, and I take Dallas to Texarkana.
Okay.
And Australia is covered by one guy. Very few people know how big Australia actually is. I think the continental US compares quite well to the size of Australia itself. How easy it is for him, if he can follow the instructions, then I don't think there's a problem. It's when he mistypes, makes a typo, click the save button at the wrong spot. He might have to buy another $3 gadget to upload the same code into it, or upload the code again into the same module. So it's not all lost. Well, we deliberately did not put the source code out first, because we want people to use this before they start hacking into the code. Because when 3 people write code, it's not always an easy 1, 2, 3 step, go change this part here, and now you will get 200 sensors. There's a few more things tangling together. So yeah, you might get 200 sensors, but your web page ain't going to show it. So there's a few more edits you need to do to get a 7th module plugged in. There's a few things that you need to understand, that everything, it goes with a 2-digit number, like Servo 1 is not /1, it's /01. And we did that because we only limit the sensors to 96. So there's no chance of going to 100. It's just /96. And in JMRI, you need to make sure that those numbers match the numbers that you put into the board, or the topic that you told the board to be at. I thought I had a bug last night where I typed in, instead of / or TX number /sensor, I type in mqTrains /sensor, and I couldn't get the stupid sensor to work. And we had a bug yesterday morning, and Joel's testing and David's testing, and I was like, they must be right. There is a bug here, but I can't find it. So finally, when I went to bed, I turned my phone on, and it said, "Hey, you have a node that's not on your, it's not publishing." I was like, "Oh, that's because I made a typo. I put the wrong address in." So it's new. It's like the first days of Wi-Fi, where you maybe had to solder a wire or two. Just kidding. But at least when you have it up and running, there's a wow, now I can afford that burger and milkshake to feel proud. So.
Well, very cool, Speed. I really do appreciate your time this morning. And fortunately, we've got a built-in representative with Joel, so Joel can just like do all this, and none of us have to even like understand how it works. So that's going to be awesome. Thanks, Joel, for that.
I'm sorry, were you talking, Riley? I wasn't listening. I faded out there.
We're recording it. Don't worry. You can listen later. But no, Speed, this sounds really cool, and I think it's something that we really want to consider for the layout. It seems like it would work really well for our situation. Yeah. So thank you for talking to us this morning, and for all your hard work on that and everything else that you do. And we will see you shortly, later on down the line somewhere.